Let's start with a quick and simplified review of what AV blocks are. In a normal heart, as the SA node fires, atrial depolarization travels across the atria. However, the signal is then slowed down at the level of AV junction to allow for atrial contraction and ventricular filling. The signal then is released through the His-Purkinje network to allow for ventricular depolarization. First-degree AV blocks are a consequence of the AV junction holding on to the signals coming from the atria for far too long before letting go. However, every single signal still gets through to the ventricles. Now, this prolonged pause at the AV node is represented on the graph paper as a prolonged PR interval. A normal PR interval should be between 0.12 to 0.2 seconds, or 3 to 5 little boxes. In other words, if your PR interval is longer than one big box on your ECG paper, then you're dealing with a first-degree AV block. In the case of second-degree AV block type 1, also known as Winky block or Mobitz type 1, you will have a PR interval that gets longer and longer and longer until there is a lonely non-conducted P wave, and then the cycle starts over again. The most important thing to remember with AV blocks is that they are a problem with the AV node and not the atria. And remember, the P wave represents atrial depolarization. So, even though the PR intervals are getting longer and longer and longer here, your P to P to P to P to P interval always remains constant. Duration of the PR interval is the key for differentiation between second-degree type 1, second-degree type 2, and third-degree AV blocks. In the case of second-degree type 2 or Mobitz type 2, even though there will be non-conducted P waves, all the PR intervals before and after the non-conducted P waves are constant and have the same exact duration. And once again, it is important for you to remember this is not an atrial problem. This is a problem at the AV junction. So all the P to P to P to P to P intervals remain constant. They must for this to be considered an AV block. Finally, in the case of a third-degree AV block, none of the P waves are conducted through the ventricles. And so you will end up with P waves and QRS complexes that are dissociated. Now, every R to R to R interval will remain constant. And just like before, every P, you have a buried P wave right there, that's why this T wave looks different than the others. Every P to P to P to P to P to P interval also remains constant. However, all of your PR intervals will randomly change. The P in PAC stands for premature. A PAC is a premature atrial complex. Now, this by definition means this complex came early. Earlier than what? Well, earlier than the intrinsic rate of the sinus node. So what this means is that the signal that depolarized the atria came from a focus different than the SA node. Now, because the P waves represent atrial depolarization, this signal over here will have a P wave of a different morphology than the SA node. So if we look at the picture over here, you will see that you have these P waves that are associated with the SA node, and then you have this other P wave that came early and has a different morphology because it's coming from a different focus. And if we were to, and this is key, this is extremely important here, if we were to march out our P waves from here to there, we will see that our next expected P waves should have been somewhere over here. However, the P wave occurred here, which means it came early. And this right here is the key in differentiating between blocked PACs and AV blocks. Now, let's talk about how blocked PACs can happen. As a refresher, remember that cardiac myocytes have what is called an all or nothing property. And what this means is that when a stimuli hits a myocyte, that myocyte will either respond to that signal or it will not. And there is absolutely nothing in between. So, if a cardiac myocyte is in a resting state or in a relative refractory period, it can and will respond to a second stimuli. However, if the cardiac myocytes are in absolute refractory period, they will not respond to a second stimuli. So, let's say that SA node fired, you had the signal that traveled that hit the AV node, and this AV node transmitted the signal down the His-Purkinje network. Now, if another signal comes from another focus somewhere in the atria and depolarizes the atria, well, sometimes what happens is that this PAC can actually hit the AV node while the His-Purkinje network is still in an absolute refractory period. So if that occurs, what you will end up with is a PAC that was blocked and not conducted through the His-Purkinje network. Now let's look at a couple of examples together. Here, as you can see by this black arrow, we have a lonely non-conducted P wave. Next, we need to figure out, is this a blocked PAC or are we dealing with an AV block? Now remember, the key to AV blocks is that all P waves across the strip must march out and all your P to P intervals must be constant. So let's look at our P to P intervals. I'm going to pick this P wave right here because it's almost right on a big box. So here is 1, 2, 3. Here's my next P wave. And then I'm going to count again. 1, 2, 3. Here's my next P wave. 1, 2, 3. As you can see, the next P wave should have occurred here. However, this P wave came prematurely. And for that reason, this is going to be considered a PAC that was blocked, because my P to P to P to P intervals are not constant in this case. Here is another example. As you can see, we have a lonely, non-conducted P wave right over here at the tail end of this T wave. Now, if we are to march out our P waves to see what our P to P interval is, I'm going to pick this P wave right here because it's on a large box. So I'm going to count 1, 2, 3, 4, 5. That's where the next one is. Even if you count backwards, 1, 2, 3, 4, 5, that's where the previous one was. So that means the next one should be 1, 2, 3, 4, 5. The next one should come here. However, it came early right here. And for that reason, it came prematurely. So this is another example of premature atrial complex that was blocked.